Hey everyone, so I want to clear up a huge misconception around project-based learning. I've heard a lot of comments on LinkedIn in regards to this. I've got a lot of comments from teachers as to why they're not doing project-based learning. I've heard a lot of misconceptions when it comes to the parent population who are demanding more rigor in schools. And I want to clarify this because I don't think project-based learning is something for a few kids, maybe our gifted students. Or something that we just do on the side. I think it needs to be the core way of delivery. And here's why. Typically, when we have, I'm going to call this, I'll put a T, traditional learning, and I'm going to call this project-based learning, okay, PBL. Now, what people wrongfully assume is they assume that when it comes to standards, so I'm going to write that bubble here. They usually attribute standards to traditional teaching. And a lot of people say, well, that's the reason why I'm not doing project-based learning is I got these standards to cover. You know, I've got this gobs and gobs, whether that's the IB standards, whether that's the IGCSE standards, whether that's the AP test, whether that's the US state standards. Standards are something that all learning has, right? We can't get away from that. And I'm not even opposed to standards. What I'm opposed to is people using standards as an excuse as to why they're not doing project-based learning. Because guess what? Really, when it comes down to learning in general, and if we called this the learning Venn diagram, PBL and traditional learning have these things called standards. You're not going to get anybody who's teaching science who's going to tell you that it's not important to do really good investigative data. It's not important to peer review things. It's not important to go through the scientific process. Everyone knows that that's important if you're learning that kind of content. The difference, though, between project-based learning and traditional learning is whereas you might learn those standards in isolation and take an assessment, in project-based learning, you're learning those standards through the project. And more importantly, and I'm going to respond to Benjamin Freud's provocation, thanks for putting it out there, Ben, is that you're thinking like a scientist. You're thinking like a mathematician. You're thinking like an entrepreneur. You're not just studying these things in isolation. You have to embody them because you have to actually use those things to solve real problems and challenges. And now I'm going to give you an example of how that would work in a project-based experience, the standards. So that's the next part. All right, I'm back, and as promised, we're going to talk about how to address those things called standards to show that project-based learning is actually quite rigorous, and I would say probably more rigorous than traditional learning. And here's why. Let's take a project like improving water quality, which is an actual project, by the way, that was run with year 7 students, and I did this in Beijing. And it all started around a provocation of the local waterway and noticing that it was quite polluted. And it was right next to our students' apartment, and they always talked about it as a stinky river. And their question was, well, how do we help clean this thing up? And so, the big question around this project is how can we use data? Data is really signifying that there's going to be some intense, rigorous standard work done to make an improvement on our local waterway. All right, that's the big question. That's improving water quality project. Now, again, I want to put to bed this idea that project-based learning is not rigorous or standards-based, because it is. What I said, though, is you're going to have to think like these different disciplines. This is English. This is math. That's science. That's humanities. You're going to have to actually think like a humanitarian. You're going to have to think like a scientist. You're going to have to think like a mathematician. And you're actually going to have to think a little bit like a linguist to be successful within this project. So not only is it standards-based, you're having to think like that actual discipline, and you're taking 4 disciplines and you're combining them on this real project. Now here's the way those things combine. First of all, let me tell you, I'm looking at a document here of the project plan, and I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 standards that were covered within this project. Be hard-pressed to find any traditional learning that can really encapsulate units and cover that many standards in a cohesive way. So that's just to start. Let's start with, okay, humanities and English. Well, how did humanities and English combine in that project? Well, here's the deal. Humanities and English, you know that English somehow is going to have to be used with improving water quality. How's it going to be used? Well, one of the things that they're going to have to do, and I'm going to put a bridge here that connects those two. Okay? The bridge is showing how humanities and English are combined, and that has to do with their proposals. Students are going to have to write a proposal as to how they plan to use innovation, use data to make a marked improvement on the local waterway. That proposal is going to have to include some really extensive research that's, by the way, done through standards of acquiring primary and secondary research, whether that be from the internet, whether that be from interviewing villagers, whether that be from experts. And when it comes to humanities, they're going to have to look at the geography of the region and see how that might affect the water quality. So that's combining two subjects naturally, and what they're doing is what scientists normally have to do. Now that proposal can't come out of just this interviews or just this primary research. They're going to have to actually be citizen scientists. That's where the S comes in. They're actually thinking like scientists. So another way to link these two is you're going to have to link science and English. And how are you linking science and English? And oh, by the way, I'm going to link all three of these things. The way you're linking that is through your field study. Yes, students are actually going to go out to the site. They're going to take water samples. They're going to analyze those water samples for the dissolved oxygen, the nitrate levels. These, by the way, are all things I didn't know initially because I'm a humanities guy, but I was working together with a science teacher. They're going to have to analyze that data. They're going to have to present that data when it comes to their proposal as to how they might clean that up. And so that's combining science, that's combining math, and that's combining English. So those are a couple of things, the real world things that you're going to do in the project. You have your proposal, you have a field study, and of course, you might actually add, and I'm going to add a little bubble here that says D for design. Now we talk a lot about this, right? We have our STEM projects, which, by the way, I'm not opposed to. I think STEM projects are great. But the problem with STEM projects is it's a pre-packaged project and it's not getting students to think critically for themselves. What if through the actual project in question, students are doing STEM naturally because you need STEM to solve this? Students are learning design because they're creating their own water filters. They're creating and designing their own eco-friendly bags, which involves taking upcycled materials or old clothing. They're designing, actually, in fact, in this project, some designing their own bamboo bicycles, right? They worked with an NGO and designed their own bamboo bicycles to help solve this, not just improving water quality, but improving air quality, because now we've got less cars on the road because these bicycles are making a statement. Every student is coming up with their own solution, and they're combining all of these naturally. Now, our job as teachers is not to drive home the standards and make sure they hit those. Our job is to look for evidence as to how they've hit those standards through the actual project itself. Much like a Montessorian way of really following the child and what they're interested in, that is really with project-based learning what it looks like. We've mapped out the standards we want them to hit. We've also mapped them to what real scientists do, what actually, real presenters do, what real humanitarians do when they're doing this kind of work, what real mathematicians do. And we've had those things as products throughout the project that students are going to have to do naturally. One thing I forgot to mention, by the way, and this is where all of this stuff comes together, is in this presentation. So I'm going to connect all of these things because culminating this project is this big presentation that students are going to do for multiple stakeholders. Now that presentation is going to be for the community to see how they can get involved. That presentation is also going to be done for real scientists, environmental engineers, to make sure that their science is sound, because if they're going to act like scientists, they want to really check that with real scientists. And it's also going to include, fellow peers. One of the presentations that one of the students did was for the local supermarket because she wanted to get her upcycled bags into the supermarket. The supermarket said, yes, we'll do that, and we'll give the shoppers here a discount. So let's put to bed the whole idea that standards can't be addressed through a project. If you're not doing project-based learning, I understand you might be afraid. I understand it's scary when you really turn things over to kids and let go of control. But please do not tell me that you're not doing project-based learning because you're afraid that you can't hit your standards. This project hit 14 to 15 of them across multiple disciplines. Project-based learning is rigorous, and it does hit standards, and it has students think like real experts in the field. I hope you enjoyed this video.